All right, so now we move to the lesson part. Our objective today, very straightforward rather. Our objective today, we're taking it one step further, is that our students are going to be able to, students will be able to solve equations that contain radicals in order to solve application problems with radicals. You know what the cool thing is about the videotaping of the lesson? Is I could almost hear you moan when I said application problems. Because you were like, oh, application problems. Which is just a fancy way for saying word problems. All right, so let's try some notes here and let's try some solving. All right, when solving radicals, equations that have radicals, this should say radical equations, not radical expressions. Glory sakes alive. It's hard to find good help. Begin by isolating the radical to one side of the equation. Then raise both sides of the equation to the power of the root of the radical. So if it's a cubed root, you're going to take it to the third power. If it's a fifth root, you're going to take it to the fifth power. If it's the seventh root, you're going to take it to the seventh power. And then you solve the equation. Once you have solved the equation, you have to check for one of my favorite math words, extraneous solutions, because we cannot take square roots of negative numbers. And anytime we multiply an equation by a variable, we could introduce new solutions. So let's give it a go here. Our first step is to see if, in fact, is our equation have the radical on one side and the variable on the other, and everything else on the other. So when we look at part A, indeed it does. So check for step 1. Step 2 then says to raise both sides to the power of the root of the radical. Well, I don't see a number here, so that means it's a square root. Since this is a square root, what we're going to do is we're going to square both sides. So when we square both sides, when you square the square root, you get what's inside. And 4 squared is, of course, 16. So then, we've got a nice little linear equation here, and we solve that. So we subtract 6 from both sides, so 2x equals 10. And then we divide both sides by 2, and x equals 5. And then we check that. 2 times 5 is 10. 10 plus 6 is 16. The square root of 16 is 4. It works. That was easy, right? And you're saying to yourself, self, it's going to get harder. Well, no, it's just going to get more advanced. Kind of like application problems. It's another way of saying it. So we look at letter B here, and if we follow our steps, the first step is to get the radical all by itself. So what we're going to do for this first step is we're going to add 4 to both sides. So now we have the square root of 3x plus 3 equals 12. We've got the radical by itself, and we've got everything else on the other side. Since this is a square root, we are going to raise everything to the second power. Because remember, if you don't see the number or the index there, you're squaring. So when we square this, when you square the square root, you get what's inside. So we have 3x plus 3 equals 12 squared, which is 144. So now we solve our equation. We subtract 3 from both sides. So 3x equals 141. And then we divide both sides by 3. 141 divided by 3, 3 goes into 14 4 times. and that's 3 times 4 is 12, so we subtract, so that's 21. 3 goes into 21 7 times, so our answer would be 47. And we check that. What is 3 times 47? Well, 3 times 47 is 141. 141 plus 3 is 144. The square root of 144 is 12. 12 minus 4 is 8. And we've got ourselves a good old solution. That wasn't so bad, was it? Now what happens if you're solving this and you have something where it says the square root of x equals -9? There's no solution. Because the square root has to be a positive number. With the way we've defined radicals in this course, we cannot have a solution there. When we square it, we're going to say that x is 81, but when we take the square root of 81, we get 9, and that's not -9. Because we're saying our square roots are going to be positive square roots, principal square roots. Now, that being said, when you look at part C, if any of you tried to confuse us, I didn't try to confuse you, I just tried to make you aware of what could happen here. When we look at letter C, I don't know why I keep saying number. We look at letter C, it says the cubed root. Can the cubed root be negative? Right. You can have the cubed root of -125, because that would just be -5. So it's okay here. We already have it so that the radical's on one side, everything's on the other. So we're going to take it to the what power? Well, the root is 3, so we're going to cube this. When you cube what's in there, you get what's in there. Equals -2 cubed is -8. And we solve. So when we solve, we subtract 1 to both sides. So we've got -7 plus 1, which would be, -8 plus 1, which would be -7. And then we divide both sides by 4, and x equals -7/4. So now we check that. -7/4 times 4 is -7. -7 minus 1 is -8. What's the cubed root of -8? -2. So we're golden, like the arches. Okay, taking a look at part D, very similar to part B. We want to get the radical by itself, so we're going to start by subtracting 4. So we've got the 4th root of 2x minus 6 equals 2. Can we have the 4th root be a positive number? Sure. Could it be a negative number? Not so much. So what are we going to raise each side to? Well, it's the 4th root, so we're going to go to the 4th power. So that gives us 2x minus 6 equals 2 to the 4th, which is 16. And we solve. So we add 6 to both sides, so 2x is 22. And then we divide both sides by x, or by 2, which gives us 11. And now we check. 2 times 11 is 22. 22 minus 6 is 16. The 4th root of 16 is 2, and 2 plus 4 is 6. Excellent. You're probably saying to yourself, why do we have to check these if they always work out? Well, sometimes it doesn't. Just when you think your life's going well, it doesn't always work out. So taking a look at this first one here, the first thing we need to do is get things so that the radical's on one side and everything else is on the other. So we subtract 7 from both sides, and we end up with the square root of 4x minus 7 equals -2. Well, I talked about that earlier. The square root can't be negative. So there's no real solution here. And that's all you'd have to write, as long as you showed that it didn't work. Now, taking a look at part F, we got to get it so the radical's by itself. So we have the 4th root of 4 minus x equals x minus 2. Now things are going to get a little bit more difficult. a little advanced. We've got the square root, so we're going to square both sides. When we square both sides, of course, we get what we had in the radical, so we have 4 minus x. And then when we square x minus 2, that's like multiplying x minus 2 times x minus 2. So you could FOIL, you could box, you could expand, whatever way you are most comfortable with. I'm going to show the foiling. That's what I'm actually doing now while I'm talking to you, because I'm pretty amazing. No, really. Thank you. Thank you very much for agreeing so willingly. And the laughter is just, it's too much. So I've got x squared minus 4x plus 4 equals 4 minus x. This is a quadratic equation. So some of you are thinking to yourself, I thought we were done with that. Well, we're never done with it. Once you learn something in math, it's always fair game to come back and bite you in the butt. So we are solving a quadratic, so we want to get the equation equal to 0. So we're going to subtract 4 and add x. We're going to subtract 4 and we're going to add x. So to do that, now we have 0 equals x squared minus 3x. Well, that worked out real nice, didn't it? Oh yeah, baby, that worked out beautifully. So now we're solving this equation, and you could solve it with the quadratic formula, you could solve it by graphing, but me, myself, and I, the three of us, we see that this has a GCF of x, so we're going to factor out x minus 3. Then we set each factor equal to 0, so x equals 0, and x minus 3 equals 0, which means x is 3. So we've got two answers here. So we check them out. So we take and we plug in 0. 4 minus 0 is 4. The square root of 4 is 2. 2 minus 0 is negative 2? No. Not a solution. We plug in 3. 4 minus 3 is 1. The square root of 1 is 1. 1 minus 3 is negative 2. This is our solution. So there are times when you're going to have an extraneous solution. So now let's take that and apply it to some word problems. Okay? Most of this is word problems. They're giving you formulas and they're asking you to solve them, and you're like, oh, please, no. No. But I digress. Pythagorean theorem. A squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse of a right triangle. You've done these all your life almost. So we've got a as a leg, b as a leg, c as a hypotenuse. We set up our equation. 5.2 squared plus x squared equals 11.6 squared. And then we do the math. I'm going to break out the old calculator. You may or may not choose to break out the old calculator. But if I break out the old calculator, now I can do 5.2 squared, which is 27.04, plus x squared equals 11.6 squared, which is 134.56. Solve that. So I'm going to subtract 2704 from 134.56. So x squared is 107.52. And I'm going to take the square root of that. So x is 10.369. So since everything was tenths, I'm going to leave it as tenths. That was easy. Okay, the next one says find the missing part of each triangle below. So it's still a Pythagorean theorem. So C is our hypotenuse, and then we've got A and B. Doesn't matter which one's which. So we've got 5 squared plus x squared equals 13 squared. Oh, excuse me. So 25 plus x squared equals 169. So x squared is 144. So x is 12. We don't have to check our answers here. We can check them to make sure we did the math right, but we don't have to check our answers here simply because we didn't square the whole equation. We're just trying to substitute in radicals. Okay, so for part 2 it says to use the distance formula, and they actually give you the distance formula. The cool thing here is it says to approximate to 2 decimal places, which means we're going to get to use our calculator. The hardest part, though, is to remember that ordered pairs are x, y. They're in alphabetical order. So when we set this up, we know the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared, which is really the Pythagorean theorem. But I'll save that for another day. So I have 3 minus 0 squared plus, since I used the 3 first, I have to use the 7 first. 7 minus 3 squared. And so I solved that. So I have 3 squared plus 4 squared, which is 9 plus 16, which is 25, and the square root of 25 is 5. Same thing for part B. X, Y, X, Y. Doesn't matter which one you use first, as long as you are consistent. So I've got the square root of 1 minus a negative 10 squared plus 50 minus a negative 10 squared. 1 minus a negative 10 minus negative is plus positive. So I've now got 11 squared plus 50 plus 60 is 60 squared, which is 121 plus 3,600, which is 3,721. And then we're going to take the square root of that, and we get 61. Well, isn't that crazy? Not the square root of 61, just 61. Aww, my pen's dying. I really, really like this pen. I really, really like this pen, but it's dying. So, oh yeah, it's gone. It's gone. So anyhow, that's that. Taking a look at the next equations. Hey, this time we're using Heron's formula. Heron's formula is something that we don't often talk about, and it finds the area of any triangle given sides A, B, and C. S is half the perimeter. So what you have to do first is find the perimeter, and then you're going to take the square root of the half of the perimeter minus the first side, half the perimeter minus the second side, half the perimeter minus the third side. So let's find our perimeter. To find the perimeter, we add all the sides up. So we're going to do 10 plus 26 plus 24. So that's 36 plus 24 is, you moron, 60. So S is half of that, which is 30. So to do our formula, we've got side A, we've got side B, we've got side C. So we're going to take the square root of 30 times 30 minus 10 times 30 minus 26 times 30 minus 24. So we have 30 times 20 times 4 times 6, which is 14,400, and we take the square root of that. Our answer is 120. And so that's our area. So taking a look at the next, change this to 2. I changed that to 2 because the triangle inequality theorem, which says that the sum of any two sides has to be greater than the third side. So 15 plus 1 is 16. This couldn't have been a triangle. So we needed to make that a 2. So we've got 15 plus 16 plus 2 to find our perimeter. 15 plus 16 plus 2, so that's 31 plus 2, which is 33. So that means S is 16.5. So we do our formula. So we've got 16.5 times 16.5 minus 15 plus, or times 16.5 minus 16 and 16.5 minus 2. So we have 16.5 times 1.5 times 0.5 times 14.5. Multiply that together. I don't know the 0.5 stuff in my head. You might, but I don't. So I'm typing that in my calculator. And I got the square root of 179.4375. 16.5 times 1.5 times 0.5 times 14.5. And then I'm going to take the square root of that. And so my answer, when I took the square root, I don't know why I keep doing that, is 13.395. And we didn't have any decimals, so I'm just going to go with 13.4 square units. Slide that up so you can see the answer, huh? Scooch it over so you can see what's in the dark. Yeah, I didn't space that one out real well. Sorry about that. I hope you still love me. And then there's your closure, which is just practice using those same formulas. So do your closure, turn that puppy in, and we'll be reviewing next class for your quiz on radicals, and then after that will be your test. So it's just winding down, folks. It is just winding down. Okay? Thanks for coming out.